Okay. I mean, then you have addition of integers. Addition of integers means when you add two integers, right? And then it has some property. So we'll discuss about that property, which is very important. So see, when you add integers, there can be cases. So first of all, if you add two integers which are of the same sign, say two positive integers, so 2 plus 3, right? So 2 plus 3, so you just add the integers if they are of the same sign. So just add the integers and they retain the common sign. So they are of the same sign, so you'll just add them and retain the common sign plus, right? If they are of different sign, what will you do? Subtract them and then retain the sign which is larger. So you subtract them. So subtraction will be 3 minus 2, which is 1, and then retain the sign which is larger, right? So same sign, there can be one more case when it is minus 3 minus 5. So again, they are of the same sign, so you'll just add them and keep the common sign. And then you have different sign, one more case when you have, say, minus 5 plus 8. So then you will subtract them. So 8 minus 5 is 3, and then keep the sign which is larger. So plus is more. So you can either keep plus or leave it as it is, right? Okay. So then addition has, so any operation that you do on integer has four property, be it addition, subtraction, multiplication, or division, right? So the first property is closure, right? What does closure mean? So for addition, it means if you have two integers, so a is an integer, so I'll write a belongs to integer. B is an integer, so b belongs to integer, right? So if a belongs to integer and b belongs to integer, or if a is an integer and b is an integer, so their sum is also an integer, right? Is this applicable to natural number? So if a belongs to natural number, b belongs to natural number, so a plus b will belong to natural number, right? For whole number also this will be applicable, right? So when this property follows, then we say integers are closed under addition, or in natural numbers are closed under addition, or whole numbers are closed under addition, right? So in some statement, or say assertion or reasoning type statement, you'll get this statement that this integers are closed under addition, or integers are closed under multiplication, right? So this is how you'll get the statement. So you have this closure property, then you have this commutative property. If you either take a plus b, or if you take b plus a, right, you'll get the same answer, right? What if one of the integers are negative? Will it follow this property? It will follow. It does not matter, because see, if this is negative, say 2, or say minus 2 plus 3, right, and then 3 plus minus 2, both ways, since they have opposite sign, what you'll do, you'll simply subtract them and keep the sign that is larger. So you'll get 1 here, you'll get 1 here, right, which means it follows commutative property. And then finally you have this associative property. So say you can either add this first or add this first, right? It will not change the result. So these are very important when you are doing or solving questions involving large numbers, right? So when you have multiplication, when you have division, or when you have lots of operations simultaneously, then this comes in handy. Then you have existence of inverses, right? So you have additive inverse. What is an additive inverse? So if you have a which belongs to an integer, so additive inverse of this would be minus of a, which will also belong to an integer, such that if you add both of this, you'll get 0, right? So if you are given a number 2, find the additive inverse of 2. So maybe you can assume this as x, so 2 plus x, because you know that this will be 0, so you'll get x as minus 2, right? And then so you have an inverse, and then you have identity for addition and multiplication. Okay, what does identity mean? So see, additive identity is something, if you do that operation to this number, it will not change the result. So additive identity is a number which will not change this result if you use it. Say if I'm talking about additive identity, we have a plus something should be equal to a, right? It should not change the result. So what should be the additive identity of an integer? 0. So this is the meaning of additive identity. Okay. So then you have some generic statements. Say for example, what is the sum of two positive integers? Can it be positive or negative, or it can be both? Okay. So the statement is sum of two positive integers. It will always be positive, right? And then sum of two opposite negative integers. It will be negative. And then sum of integers with opposite sign. It can be either positive or negative, right? Depends on which sign is greater. Okay, so this is all about addition. Then you have
The same properties for multiplication, division, subtraction, which we'll discuss in the next class.